chapter 6 is nonlinear equation solutions and optimization problem solutions. And in this chapter, I want to explain the following topics. First is how to solve nonlinear algebraic equations. We have learned how to solve linear equations or matrix equations. So the topic here is how can we solve a nonlinear algebraic equation. Also, we want to discuss how to solve unconstrained optimization problem and other optimization problems. I think this part may reflect or may change the way of your research if you learn this one, and if you apply this one to your own research, you may find different solutions to your own problems. For instance, the normal way to solve a problem is we just find a solution to a certain problem. And if you learn how to perform optimization, you may consider how can we find the best solution to it. We can specify our criterion or performance index or objective function to the problem and how to find the best solution. And if we use Matlab, this kind of problem can be solved easily. And then I'll talk about constrained optimization, including linear programming, quadratic programming, and general nonlinear programming. And then I want to talk further about optimization problem by introducing mixed integer programming problems. LMIs, I'm not quite sure whether you have applied LMI or read something about this. If you are interested in, I can talk something about this also. And apart from this, I will talk something about dynamic programming and shortest path search problems by Matlab. So now let's consider how can we solve nonlinear equations, nonlinear algebraic equations. For differential equations, I will leave on the seventh chapter. Now I'll just concentrate on how can we solve nonlinear algebraic equations, and have this guideline of this section. One is how can we solve nonlinear equations using graphical method. How we draw graphs and find all the solutions. So graphical-based method, how can we find the solutions? And the other one is for polynomial type of equations, how can we find the analytical solutions? To be specific, we cannot use the word analytic, we cannot use quantity analytic, because the analytical solution to certain polynomial equations does not exist. We have to find a approximate analytical solution to the original problem. And then we want to talk about how can we find the numerical solutions to ordinary nonlinear equations, which are the extension to polynomial type of equations, which refer to any nonlinear algebraic equation. How can we find the solutions to them? And then I want to talk about nonlinear matrix equations. How can we solve them? So these are the equation solving problems. So let's consider how can we find the solutions to nonlinear equations by graphical method. By the word graphical, it means that we can only solve the problems with one variables or two variables. We cannot solve the equation using graphical method for more than two variables, because it is not possible even in Matlab. So now we will consider first how to solve an equation with only one variable, and how can we solve equations with two variables. Let's consider an equation first. Suppose this is an equation that contains only one variable t here. So to solve this equation, this means we have to find the value of t such that the original equation holds. How can we find that solution? What we need to do is to specify a vector T and then find all the values of the function and see and draw the curve and see the value of the curve, the intersections of this curve with the horizontal axis. So these are the solutions. If we can find them, then we say that we found the solution to the equation. Alternatively, we can use easy plot function, and we can solve the problem easily by calling is plot function. And here we can specify the original equation first, and quote the original equation, and specify that we can draw the curve in the interval 0 to 5. So we can use this command to draw the curve and then we use the command line to draw the horizontal line. X-axis. So in this case, we say that these are the solutions to the original problem. But how can we find the values there? What we need to do is to use the zoom facility. For instance, we want to find the value here. We can zoom this point until that all the scales in the horizontal axis is the same. Then we say that this point is the numerical solution to the original problem. So 2.5937. 5937. So this is the solution we found. Now the question is, if we substitute this solution back to the original system, what will be the error? So we copy that part again. Minus 5. And we say that this is the error. The error is small, but it is not quite small. So in this way, we can easily find the numerical solution to the original problem. Why we cannot find a even more complicated, even more accurate solution? Because we are only allowed to read the solution with 4-digit decimal point numbers. So we cannot get even much accurate solutions in this way. And the advantages of using this method is that we can find the solution, we can find all the solutions within the interested area. We can find all the solutions in this way. And the disadvantage is that these solutions are not quite accurate. So there are advantages and disadvantages in the solution of the original equation.